Hey, good evening, everybody. Back for the 8 o'clock weathercast, and you can see the tropical moisture streaming northward. This is it right here, up at about 3,000, 4,000 feet, coming up northward, and maybe I'll show you a bit of that on the 850 chart, so you can see the flip side of that. There's the radar presentation. We can see those storms that we've had over northwest Texas. They've broken up a little bit, so we just have this one cell. This has moved northeast from the Haskell area. Doesn't look too bad right now. The stuff further north, this is deeper in the cold air, which we'll check out shortly. And what's actually happening at this point, we're now seeing the development of a squall line out in West Texas. This is the cold front coming out of New Mexico. We can see that here on this SPC mesoscale analysis. In the basic configuration and boundaries we have this evening, we've got kind of a warm front, something like that right now. So there's that right there. The actual cold front is right there along the squall line. Out a little ahead of that, we've got a dry line sort of in this area here. That's about to be undercut. And then further northwest, we've got the tail end of this cold front. So there may actually be a few chasers up in this area, maybe trying to get a few photogenic storms. But there is a little bit of news you've probably heard if you've been on Facebook or Twitter that there's been a couple of chaser fatalities out around Spur, Texas. And I don't really know too many of the details. You can find a lot of that on social media right now, but that took place around Spur. And I'm not sure if weather was a contributing factor. Again, I don't know the details of what went on exactly. I do know it was a multi-car. There was 2 cars involved, but whether weather was involved, I'm not too sure. Okay, so squall line out to the west. Let's check out the charts here, go through the chart sequence. Well, yeah, there's the current weather there. You can see the clustering of the tornado events, mostly right there along the Caprock east of Lubbock, and then just north of Abilene right there. Okay, 500 millibar chart. This kind of goes back to the beginning of today. So this is up at 3 kilometers, or 5 kilometers, or 3 miles. Upper level low over the northern Arizona area. Polar front jet rounding the base of the trough right there. Maybe about to go into the base of the trough. I'm going to go with this 80-knot wind right there at Yuma. So stronger winds on just west of the trough axis. And what that means is that this trough is more likely to deepen further. Usually if you have the strongest winds on the other side, that will tend to lift the trough out and bring it northeast. So this trough is definitely headed for the Texas area. Here's a satellite. Here's a view that we never really see. Things look pretty peaceful down there. There's no map contours, but if you look just a little bit, if you look really close, you can see the Gulf of California right there. There's the West Coast. There's Mexico and Texas right there. So the big storms over Texas located right there. So you can see how big the anvil is on this MCS here. So we can go a little bit closer by looking at Macitas. There's the visible imagery from about half an hour ago. And you can see gravity waves on the top of the updrafts there. See right there? So you can see not only the overshooting tops, but the area where the overshooting tops have spread out, and then the downstream ripples where you have oscillations underneath the stratosphere. So if you're lacking radar data, like maybe you decide to chase in Mexico, maybe you're chasing way down here, You can use satellite data to a certain extent to find your more intense cells. So we can pick out right there, got a couple of strong cells, right there, here, and further down in this line. You can kind of go through and just find where the most intense activity is. And one other way you can do that is to look at the infrared imagery. This is the infrared imagery for northwest Texas. Here's the Panhandle. Here's West Texas. And we look for the coldest tops. For example, right here. And that's where the updrafts are rising, punching up through the tropopause and reaching the top where the momentum of the updraft bleeds off. Then that settles back down and forms the anvil as it spreads out. Excuse me. If we animate that, look at that just briefly, we can see what looks like a little bit of a intense cell right there around Crowell. And we can see that the stuff further down in West Texas doesn't really look all that intense. Nothing like what we have up in the Childress area. And I'm kind of surprised. I would expect that maybe a few of these would be a little more intense than what we saw. Here's the thickness chart. And in this case, I'm using 1,000 through 850 millibar thickness. So I'm taking a slightly shallower layer, which is fine to do on the Great Plains where things are pretty flat. And we can use that to pick out the front, suggesting maybe either between I-30 or maybe south of I-40, somewhere in there, and then following up through northeast New Mexico and then northwestward. So that right there is the polar front. Other than that, not much to look at. Very quiet out west, and maybe a bit of a weak frontal boundary out in Virginia here, maybe along the west coast right there, or the east coast. Okay, before I get too much further, I'll take a look at chat and make sure things are in order. While I do that, I'll zoom in on these cells right here around Seymour and Haskell. Okay, hello to Ryan Toomey's, Andrew, Sue M. Saw a lot of you earlier. Mark is here, Sue M. Again, and her and Mark are talking a little bit about that news there in Spur. Greg S. is here, Lexi, David Holcomb, 60,000-foot cloud tops in South Mitchell County. Tree Nelson is here, Kevin McKinney, Ahmed in Saudi Arabia, Brian Harp, Brett Dean, and Eddie W. Alexi says it was driver error due to someone running a stop sign. That's probably about as much as I've heard. Ron Chalfonte in South California, big difference. Michael Burrell enjoying the broadcast earlier. Tom J. and Sarah Wood, Mike Estwick, 41 in Denver. Wow, that sounds really nice. I'm reading 76 degrees here. Could definitely use some of that cooler air. Okay, looks like we got a little bit of a bow echo shape on this one cell here. See that right there? Take that down further, and that could just be an artifact, but maybe there's a little bit of wind in here. Let's see what the base velocity shows. Shows a lot of red. This is probably not the ideal color scheme, but I'll switch over to, what I can do is go to spectrum width, or I'm sorry, the storm relative velocity, and I can set the motion vector to 0, and that'll give me ground relative. Okay, so what am I seeing here? Showing about 65 knots over here. and then a little bit weaker down in the south. So a little band of stronger winds right here. I'll set a dot where that is. So actually, yeah, right there along the leading edge of the storm, just ahead of these downdrafts right there. And we go up to higher tilts, and you can see more of that cell right there. There's 2.5, 3.2. So I guess we're getting a little bit more of a windstorm mode here. Okay, working down the line, we've got a bit of a hook echo on this cell near Haskell. Let's check it out to see what kind of velocities we have in that. Let me set the motion vector here. We'll go for 210 at 20. And looks kind of on the weak side. I see one little area right here. Let me set this up where you guys can read it. Okay, so there's the velocity scale down at the bottom. So we got this one little band here of 45 knots. This is outbound from the radar like that. And that's about all we're seeing, really. No strong inbound. We'll go up to the next higher tilt and see what that shows. Again, we just have a lot of inbound, so I guess we have mostly just a lot of inflow into the updraft. There's 46 right there inbound. So I guess we've got maybe a little bit of a LP-ish updraft going on here, I would think. There's 1.4, 1.8, so we're getting up to about 11,000 feet. And we pick up the core right there. And this is a good opportunity to look at overhang. So yeah, this storm does have some overhang. There it is right there. This is up at 27,000 feet. And this is at 34. So I'm going to look at that. I'm going to go with this top right here and relate that to the low-level structure. So yeah, that's certainly some overhang. And let's do a cross-section from here through that updraft area. And this is the storm right there around Haskell. So this is the south side. This is going further north. So this is basically the updraft area right there. So air is going into the storm and then up. And this is a good hail production area up there at the top of the storm. See if we have some elevated. Yeah, right there. There's some high elevated intensity, so that's probably some good sized large hail. We'll see if we can find that aloft real quick, and then we'll press on. Yeah, I think that's what we're looking at. That's probably that hail core. This is up at about 23,000 feet. So that's some stuff you can do looking around at some of the radar data. And let's see, let's go on down to the south and see what's going on further south. This is the new line coming through Big Spring. Looks like it's making good progress eastward. Lots of severe warnings on this and a couple of tornado warnings. So let me switch over to San Angelo and we'll start looking at this. And while that loads up, I'll go through some of the other charts here. Let's check out Midland. Look at their SQT. And I think the squall line was on the area around that time. This is a very interesting SQT. It's dry adiabatic from the surface up to about 14,000 feet. I think this is, I think that's got to be behind the squall line. Yeah, see right here? There's a squall line. Midland, Odessa is right in this area, and they would have been launching the balloon probably right around that time there. So this is just behind that squall line there. So very good winds aloft right there. There's 110 knots, and looks like some good moisture in the mid-levels. Okay, down to the south, Del Rio. That's the moisture supply down in that region. So looking at about 13 grams per kilogram, about 100 150 millibars deep. Very good lapse rates. That's very impressive. Let's check out Fort Worth. Also some very good lapse rates from 500 down to 700, but this is pretty far ahead of that upper level trough. Some pretty deep moisture, not all that rich, but we can see it here from about the surface where it's about 60, and then by the time we get up to about 850, it's about 50 degrees dew point. So yeah, we could squeak out some decent parcel lifts out of that. There's the capping we have in Fort Worth right now. And the approaching wave will break down all of that by changing the upper level profile to where it looks more like that. So that'll weaken the cap here, and the cape we're going to have later on as that comes through. That's about a good 1,500 to 2,000 cape value right there. And how about those upper level dynamics? Let's check this out. Okay, there's 0Z right now. So a few weak waves coming through aloft over West Texas, over these storms. The bulk of the stronger dynamics on the backside right through here. And the highest winds I'm seeing are right in this area, so they're rounding the base of that trough right there, about to come out into West Texas. So overnight, this is midnight, about 6Z. Stronger dynamics coming out of the Big Bend area into San Angelo and Lubbock. And then by 6 a.m., that will be spreading out over the rest of North Texas. Okay, so that trough will hang around for a couple days. You can see the cold core low going over Oklahoma here on Thursday. Then we get the ridge building in, and then the next wave settling in and making itself at home over the weekend. 850 millibar pattern. This is up at 5,000 feet. We'll check this out real quick. These are these clouds you saw in the opening video. You saw some cumulus clouds going north, representing some of the tropical moisture. They were riding on this 40-knot flow you see here. So this is where those clouds are at. They're up at about 850 millibars. And then the fronts are a little bit further to the north. There's the warm front, and then the cold front running something like that. So this is actually the Canadian front here, and it's hard to say where the Pacific front is, but it's probably going to be back in this area here. Okay, let's press on. And I think it's time to start looking at some of the model data. So let's jump right in and look at the high-resolution rapid refresh. This is going to be the run for 23Z. So this is the 1 hour forecast valid for 0Z. So this is about right now. So that looks pretty close. I think the squall line may be a little bit ahead of all this. So that's one thing I would do, especially when I'm dealing with a squall line like this. Check the positions. So if I go to this map here, I can see it's 0120. The squall line is just about to Tom Green County. And looking kind of like that. So how does that compare? 0120 is going to be about between here and here. I think the model is pretty much right on. I think it actually did a pretty good job. So I think we're just going to run this forward, and we can see that those northern storms mostly run up I-44 into Oklahoma. And then here comes the cold front marching eastward across the big country, which is the area around Abilene. So by midnight, they're going to stretch from about Wichita Falls to Eastland, and then down to about Junction, coming up on Kerrville. And then overnight, they'll be making it into the Dallas area. So this is going to be about 3 in the morning. So it looks like maybe we're getting a little bit of dissipation of the line. I don't know. I guess maybe it's the intensities were remaining about the same. Okay. So not much change to the line, just continuing to march eastward. And then by 6 in the morning, it's going to be looking like this right here, stretching from just east of San Antonio in through almost to Palestine and then up to McAllister here. And here's the cold core low aloft. That's also going to be moving in tomorrow. So maybe a chance of some showers tomorrow through Thursday in Oklahoma here. Okay, let's go ahead and move on to the week's forecast. So starting out on the GFS here, thunderstorms move eastward across Texas tomorrow. By the time we do the webcast tomorrow night, the GFS thinks that they're going to be in the Arkansas, Louisiana area. And I wonder if this is a little bit slow here. I'm thinking maybe the storms, I would imagine they'd be a little bit further west or east than this. But in any case, the upper level low moving through the Wichita area right there. Cold front, probably something like that. Warm front up to the north. And this will mostly move towards Illinois and Indiana later in the week. Very weak shot of cold air coming south in the wake of that, because here comes the next system through the Rockies, and this has a pretty good punch of cold air on the backside. You can see the 540 line coming all the way down to the Grand Canyon area. So this is on Friday. This is Friday morning here. And then by Saturday and Sunday, coming in through Texas. Looks like it's weakened quite a bit. Another chance of showers and thunderstorms in Texas over the weekend into Monday. And then next round coming in from the west. Excuse me just a minute. Okay, so just a succession of waves coming in from the Pacific. This is April 7th, then April 8th, kind of a quiet period here. And then we get to the very end, and looks like it's got a little bit of a cold core system off the west coast right here. So maybe another chance of rain here coming up around midweek, and lots of thickness lines in here So probably another Pacific storm starting to set up around the middle of the month there. Okay, so let me take a quick look at the chat, and before I do that, I'll put the radar up so you have something to look at. Actually, before I go, I'm going to mention these storms. I can already see that they look kind of outflowish. See that outflow boundary right there? It's pushing out about 8 or 9 miles out ahead of the storms. So that's a sign that the tornado potential is probably a little bit lower. It's kind of difficult to get a good organized mesocyclone and a tornado when you're being undercut by cold outflow. So there are tornado warnings on this line, on different parts of that line, but that doesn't mean you can't get spin-ups along the leading edge or bookend vortices. Sometimes that'll happen when you get a good bow echo developing. So let's take a quick look at the storm relative velocity and look at the circulations. Back that up just a little bit. I want to find out why they put this tornado warning out. Yeah, it looks like they might have seen a little circulation here. This is probably a vortex on the back end of that, what looks like a little bow echo right here. I'll put a dot right here. Nope, I'm sorry, that's on the leading edge actually. Let's see, so what's going on here? See, one thing that you can definitely, that really stands out, is the very strong reflectivity gradient. See that right there? You go from like 50 dBZs to about 35, 37 in a very short distance. So there's that circulation right there. We can go up to a higher tilt and maybe see what's going on there. Looks like probably a meso going right there. Then we go up to 1.3. Yeah, that's a pretty good meso right there. And a storm with higher tops. There's 2.3, 3.1, and then all the way up to 6.3. And there's a little top right there. That's up at 45,000 feet. Okay, then we'll work down the line and check on that other tornado warning. Let's see, why did they put out that tornado warning? I don't see a tornado signature, but I do see what looks like maybe a bit of a bow echo here. A lot of times when you have a good push of a bow echo, not only can you get damaging winds, but sometimes you'll have spin-ups on the left side. So we're talking about this area right here. So they may have been looking for the potential for something to develop. Yeah, there's some very good inbounds right there. This is about 61 towards the radar. So I'm sitting here thinking, I suspect what they were seeing here was probably a bit of an isolated supercell kind of embedded in this. And there's the hook. And you can see the outflow is kind of pulled into the circulation, kind of like that. So I suspect they were looking for some sort of vortex right in that area. Yeah, there's the storm relative velocity. Let me see if I can tease out some details by switching the motion vector. Let's see, I can't see anything that looks imminently dangerous, but I do see what looks like maybe a bit of a mesocyclone right there along the leading edge. So anyway, that's a pretty cool setup right there. And then further down the line, looks like a pretty good cell all the way down there at Sanderson. Anyway, this will continue moving eastward, and probably what I'm going to do is, as that comes closer to Dallas, if it looks like it's going to be severe as it gets into this area, probably what I'll do is I'll run a webcast a little bit later tonight. And if not, then I guess we'll see you all tomorrow, so it'll be one or the other there. Yeah, the storms will get here, but I'm sure I'll make it just fine. I'll try to get some lightning video, hopefully no tornado video. But let's see. Anyway, I think that'll probably do it for me, and we'll probably see you a little bit later. Anyway, have a good evening, and take care.